सही है क्या हो गया wait क्या scene okay so we're back with weird dudes special cameo appearances this time we have bad TA and Ali that sounds wrong वैसे like I mean have you never watched Bad Teacher like you're quite literally bad teaching assistant that care whatever so yeah complete the diagrams to show the energies of the electrons in a carbon
So yeah, I
atom
just got ratted out here. Oh my god.
क्या हो गया सही है कार्बन एटम में क्या आता है 6 होते हैं ना 6 इलेक्ट्रॉन्स
6 electrons होते हैं, so you have
2
what?
2s
2
sorry excuse the shitty handwriting so yeah
and 2p2.
my bad 2p2 so you draw इधर फिर आपका 2s आ जाएगा इधर कहीं and then you draw SA and you draw that for this
And you
this
draw
as well right
p.
and इसमें you draw P should we draw
Single
properly
electron.
properly draw करना चाहिए वैसे I don't know does it matter does it not matter yeah doesn't really matter
It does matter.
सही है
So you have 2 single electrons.
इसमें positive है
There.
so you just you know just draw one
One less electron. So
just draw one
एक डब्बे में arrow आएगा.
sorry okay इसमें क्या
Why the hell did you make that double arrow?
sorry
Why not?
I mean like that's just how they denoted it so I don't think it matters
Okay. Oh, sorry. My bad.
सही है good है
Change is difficult.
Basically,
you drew this then you just removed an electron added an electron
The only thing of note to know that you should have known was that 2s has a lower energy than 2p. That's the only thing this is asking really.
Yeah
Along with the electronic configuration.
and that the 2p electrons are singly spaced.
Yeah.
Anyway, next part.
buckyball what is the hybridization of the carbon atoms in C60 if you look at this is all carbon right so carbon is attached to 1 2 3 चौथा bond तो नहीं दिख रहा ना
Nope.
so
There's
sp2
3 bonds, which means sp2 hybridization.
so yeah
Yep.
it reacts with excess of hydrogen to form a single product C60Hx using our answer in 1 suggest a suitable value for x if it's sp2 which means uska ek orbital khali pada hua hai which can form a bond correct
So each carbon forms one more bond. Yep. And that means you get 60 hydrogen.
basically methyl benzene can undergo different reactions to form the products shown below give the reagents and conditions for these two reactions so first reaction mein side chain ke sath reaction ho raha hai free radical substitution you just
Free radical, yeah.
so you have
Which means it's UV light and
Cl2
Cl2.
in UV light AS reaction है ये हमने पढ़ा था इसमें and in this reaction 2 this is electrophilic substitution so here you would have
Alkylation.
sorry
Alkylation. This is Friedel-Crafts substitute.
alkyl group तो
We
है
have specialized name for it, yeah.
so yeah you add dark because
So yeah, you have to use CL3.
Yeah. this is your catalyst
Dark you write to avoid confusion.
yeah so dark ताकि वरना वो side chain के साथ free radical but this stuff would start to happen name the mechanism of reaction 1 free radical substitution right
FRS.
Yep. FRS.
free radical subs draw the structure of the product obtained if reaction 1 is carried out using an excess of chlorine so it will just keep substituting all the hydrogens available in that side chain so it will be CCl3
4.
3. Yep.
हाँ वो एक बॉन्ड तो बेंजीन के साथ ना स्ट्रक्चर बोला है तो is this fine displayed formula तो नहीं बनाना
Yeah, it's fine. 1 mark.
That is fine.
yeah calcium metal reacts with chlorine gas to form calcium chloride Write an equation including state symbols to represent the lattice energy of calcium chloride. Okay, so I know
Lattice
for
energy is basically
I know for a fact, yeah, कि
ionic
इधर
gas.
ये तो solid बन रहा है. Are these gaseous ions?
Gaseous ion.
Gaseous
Okay,
ions.
so
So it's
Ca2
Ca2 plus
positive
gas
gas plus
and
2
2Cl
2Cl
negative.
minus.
negative and again gas. So yeah, and you have final solid. That's the idea. It forms a solid ionic compound. Complete a
Mhm.
fully labeled Born-Haber cycle that could be used to calculate the lattice energy for calcium chloride because you can't calculate lattice energy experimentally. And इसमें ज़रा well दो mark है तो I don't think it's ज़्यादा ख्वारी है. So you just need to basically go to this stuff so you can get back to. You just need to क्या कहते हैं get this
So
somehow so that you can go back to
the
calcium.
solid.
Yeah. So
Yeah.
Ca इससे अगर हम
The
atomization
first step is to make it gas, Ca gas.
is that atomization?
Yep.
Yeah.
Yep. So you have
And chlorine की भी chlorine की bond energy होगी, sorry.
Chlorine bond breaking. Break the bond of chlorine.
so you have and then you have
Bond
2
energy of
Cl
Cl2.
gas. Atomization is
Then you
endo.
have,
These are both endothermic processes, right?
yep,
Yep.
Yeah, yeah.
Okay. इसमें अपने you just do first
first and
plus
second ionization
second
energy.
ionization energies, which are obviously
Of
endothermic.
calcium.
Sorry.
Yeah.
So yeah, and is
And then do chlorine electron affinity.
okay. So
Chlorine's electron affinity is actually uh,
It will go down a bit. Huh?
yeah, it's because the first electron affinity is exothermic, then the उसके बाद वाली I believe endothermic होती हैं.
Yes.
So this is 2 into electron affinity of chlorine, because there are two atoms. So Ca2 positive plus 2Cl negative, and both of these are gaseous, obviously. And then
And
what?
and
now we
then
can
this goes all
get
the way
that
down
equation.
to
Yeah,
that with lattice energy.
this is lattice energy, which is what you need, and they probably want us to calculate it now. Yeah, that's what they want us to
Yeah.
do. So क्या कहते हैं कर लेते हैं calculate क्या सीन है. So you just अबे यार इसमें ख्वारी बहुत है. Enthalpy change of atomization of calcium को 178 लो. You add bond energy of chlorine, which you can get from your data booklet जो खुली हुई नहीं है. So you'll go from this data
This is
booklet.
242.
Oh, you checked? Chalo, good scene.
Huh, I have it open.
Okay, so 242. So you've added basically these two. Then first plus second ionization energy of calcium you have to add. That again you can
Which
check from your data
is
booklet.
590 and 1150.
So 590 is the first. Then you add 1150. So yeah, then you add or rather subtract to जाएगा because exothermic है. 2 into electron affinity of chlorine atoms. So you don't, but you can add that. वैसे इसका sign is negative, so exothermic ही है. So plus 2 into minus 349. Excuse the handwriting. Right. सही है. हम कहाँ तक पहुँच गए? We basically went all the way like this. And इसमें if you plus now the lattice and enthalpy change of lat, so this should be
This
equal
gives
to
you delta HF.
enthalpy change of formation. Enthalpy change of formation दी हुई है हमें, लेकिन I believe क्या सीन है enthalpy change of formation? It is given as minus 796. So yeah, so basically now you just add it and make enthalpy change of lat जो भी है the subject, and you will get the answer. Entropy is a measure of the disorderedness of a system. Describe and explain what happens to the entropy of a gas when the temperature is increased. So if temperature goes up, the kinetic energy of the gas would go
The
up.
particles gain kinetic energy.
Yeah. So
So the particles move
They
around
move
more,
more
which means
rapidly.
entropy increases.
They more collision.
more rapidly, like though, um, more collisions, like though, use the spelling. Main idea is entropy increases. So yeah, the table shows 4 reactions. For each reaction, predict the sign of the entropy change. So increases positive sign, decreases negative sign because change. If you predict no entropy change, right, no change in the table below, the first one has been done for you. ये थोड़ा जाना पहचाना क्वेश्चन लग रहा है, बट खैर. सो पहला तो किया हुआ है इसमें, you were going from 1.5.
There is a gas to a solid.
Yeah, that's another way to look at it. Gas to a solid, matlab entropy change should be negative because kam ho rahi hai. Another way to look at this is that this was 1 mole, this was half, so you're going from 1.5 moles to 1 mole. You go to fewer moles, you have less entropy.
You decrease
So
entropy.
yeah,
Yeah.
even more negative.
Yeah. हाँ, तो और भी नेगेटिव जाएगी. If you look in this case, CO SO4 वाला
The
केस में
same thing.
same idea, you're going from 6 moles to 1.
Again,
Yeah. In the next one, you're going from 2 moles to 3 moles. That's one way to look at it. Another way to look at it is either solid hai, solid and aqueous, and either aqueous, gas, liquid. Matlab, the state is such
Gas
that,
and liquid.
it's
yeah, that the entropy would be larger. So those are 2 ways that could explain that. One is the moles, number of moles. One is just the state. You're going to a states where it's more motion and higher entropy. I I mean, Imad, how would we explain वैसे कि why do gases have the highest entropy and solids have the lowest? Is it motion?
because they have the most movement, right? Because they have the least bonds.
More movement, more
Because they
chaos.
have more movement, more chaos, and more entropy, basically.
Chaos. Okay, explain why the entropy change of the first process is negative. Entropy कम क्यों हो रही है? अच्छा, here the thing is, they're all gases,
Just
right?
write
So you can't write that. You have to write कि either 2
But
moles हैं, or like 1 plus 1, and either you're going to 1 mole. So like fewer
you're
moles.
decreasing the number of moles of gas, which means entropy is decreasing.
Basically moles हमने कम कर लिए. That's the idea. So entropy कम हो गई. And since change है, so that's negative. Calculate the standard entropy change for this reaction, and they are given. So standard entropy change is product minus reactant, right? So
Yep.
you just calculate. So it's 193. That is this. And then you subtract this. Subtract by 192 plus 3 into 131 should give you entropy, and you'd get some value of that. So yeah, whether or not a
And we
chemical,
need that value.
sorry,
And we need that value.
acha, so I'll pop it into the calculator. 192 plus 3 into 131. In fact, ये क्यों खाली कर रहे हैं? We can just simply marking sequence के छापा मार लेते हैं. Okay,
Do we need that value?
Oh my
खैर
god, हाँ कुछ नहीं सही है.
Kera, we got it anyways. Like, whether or not a chemical reaction is spontaneous, is feasible, can be deduced by calculating.
Delta G. Delta G.
Yeah, say and the idea here is if it's delta G is negative, then it's spontaneous.
Yeah.
At that temperature.
So yeah,
And
at that.
delta G is basically delta H minus T delta S.
Minus T delta S. And a very dumb, well, not a very dumb, but like something I used to get confused in. I'm like, yeah, like in T be to negative ho sakta hai, but T is in Kelvin, so T can't be negative. So T
And another stupid mistake that people can make is the units. as entropy is often in joules and not kilojoules, whereas delta G should be in kilojoules.
Oh wow.
Yes, you need to convert units.
That's मतलब या तो आप डेल्टा एच को जूल्स में कर लो या तो एंट्रोपी को किलो जूल्स में कर लो, एक ही बात है ना.
But often we
Because we
require
only need to
a
look at the
value of
negative
delta G in
sign.
kilojoules. Often we require it as a part of our question.
चलो.
So that,
Do we?
I mean
yeah,
Really?
not here maybe, but like generally शायद बात बोल सके.
yeah.
सही है.
If it's
Like above,
asked.
if you look above delta S, they've already given the units they want delta S in. That's and in the same way they often give delta G's units.
Well, चलो बेचारा, I think mic तो सब बंद हो गया. हाँ. I was your last word units, so were you saying something else? My internet connection is unstable. Why is it unstable?
You can just move on. It's nothing important.
Nothing important. Okay. So this is 117 into 10 to the power 3 because kilojoules minus 298 into change in entropy 175. So basically I've just converted enthalpy change into joules, or you could convert entropy into kilojoules, whatever. So this would be minus 298 into 175. This would be 64850. सही है. And just to put Ali's thing
Negative
to
or positive?
positive.
Positive.
And Ali's died with that, with regards to that, that they normally, I mean, I'm sure they'd expect it as long as you write the units, but they normally want uh, change in G in kilojoules. So you just divide this by 1000, which makes it.
Yeah, even if you just look at it, it makes more sense. This is too long.
Yeah, basically. And this is positive. And now you have to explain whether or not this reaction is spontaneous. It is not spontaneous because positive. Is
At
that
this temperature.
good enough? Yeah, at this temperature. Is that good enough of an explanation? So yeah, this is positive, not spontaneous at 298 at this temperature, basically. Good scene. Complete the electronic structures of the following species. यार कोबाल्ट का क्या सीन होता है? कोबाल्ट का कोई
Data booklet.
डेटा बुकलेट डेटा बुकलेट, that is the
Last page.
yeah.
We need periodic table.
Okay, so CO, where is the CO?
So after
Okay,
argon core, it's
27.
4s2
It's number 9.
3d7.
Yeah, so it's 27 and 18 हमने already argon में डाल दिया. So what they mean by that is basically आपका जो
After argon,
1s2 2s2 2p6 3s2 3p6, right? Argon is 18.
Yep.
Yeah. So all of this is just condensed down to argon. We just go after that. So 3p6 के बाद क्या है? 4s2
4s2 3d7 for cobalt.
3d7. And with this, they're just testing an AS concept, how you fill electrons first in 4s rather than 3d, and you take out electrons first in 4s rather than 3d. And उसका full concept था 4s 3d. हमने पूरा chapter
So
पढ़ा.
यहाँ पे 3d7 होगा instead of
Yeah.
getting rid of the 3d one.
So you just take the 2 out of 4s. So you fill and take out from 4s first, then from 3d. In an isolated transition metal atom, the 5 orbitals have the same energy. When a transition metal ion forms a tetrahedral complex, the d orbitals are split into 2 groups of different energies. Say, complete an orbital energy diagram to show this, indicating the number of orbitals in each group. तो in isolated आपके पास क्या होता है? Do we have to specify? But we can specify anyways. It's dxy. You have dxz, dyz, dx square, y square, and this one is dz square. And the important thing to remember is that these two can be considered to be on the axis. So if the ligand approaches from the x's, it will repel these two to a higher energy level. However, in the case of a tetrahedral complex, the ligand or however you pronounce that thing, it approaches between the x's, so it repels these three to a higher energy level. सही बोल रहा हूँ?
Uh-huh.
So you have these three,
That is right.
and then you have these two. ये दो इधर चले गए, ये ऐसे चला गया.
Yep.
So cobalt 2 forms a 6 coordinate complex containing 3 water molecules, and 3 chloride ions. Write the formula of this complex showing the overall charge if appropriate. So you have cobalt, you have H2O के कितने 3,
3
you have
and
Cl
Cl.
negative 3, and the overall charge if
अच्छा
you look
नेगेटिव यहाँ पे नहीं जाएगा, नेगेटिव
Cl,
Cl पे नहीं जाएगा.
but like CL
Yeah.
नेगेटिव ओवरऑल चार्ज तो अलग बाहर आएगा, लेकिन CL नेगेटिव तो इधर नहीं दिखेंगे ना, because it's the
नहीं,
chloride.
because the
No.
charge on Cl gets spread out.
You just yeah.
The
You
chloride
just,
ion doesn't stay as an ion.
yeah.
All right. So but khair, if you look at oxidation states and so on, so this is negative, so this will be 3 negative,
So cobalt has 2 plus,
this will
then
Plus
be
2.
0,
has 3.
and this is cobalt 2, so it's 2 plus. Overall charge would make
So
it
overall gives you a minus.
Minus
1 minus. And if you just
Yep.
get some validation from the marking scheme, yeah. Okay.
validation. So much insecurities.
I actually didn't know about the CL wala scene. You know, you don't write negative here, but care, sad life. So explain with the aid of diagrams how many isomers of the complex in one exist. Say so this is a tetrahedral complex, I believe. Sorry, octahedral complex.
No. This is octahedral.
Yeah, because it has 6 तो octahedral हो जाता है.
Yeah.
And इसमें optical isomerism होती होगी, I guess. I'm guessing. Cobalt आपके पास है.
इसमें हाँ, so you get trans and then you get
तो cis trans कर रहे हो?
optical cis. अच्छा नहीं, wait. No. This has 3 of them, so there's no cis trans.
Well, let's draw them and see. I'm not. So either optical तो हो सकती है ना? Are we sure about that? If you want to draw optical.
Not sure about that either.
I mean,
you can get 2 types of isomers. One of them where there is no opposite sides पे सारे different है. Right? So like if H2O is on one side, then the opposite side is the Cl. That's
okay.
one isomer. The second one is what you drew there.
But even but
I'm not sure if it has optical version or not.
Because एक side पे change हो रहा है, दूसरे side पे शायद flip नहीं हो. Because into the page तो they're all just CLs, but out of the page पे भी flip हो रहा है. Because what I mean is like this with regards to these two, there's still a change being shown. That's one thing. What else were you saying? Hello?
And then you have like opposite sides for different ligands.
Okay, so opposites. So like up and down मैं chlorine लगा दूं, would that work?
ऊपर chlorine नीचे H2O like.
सही है. So हमने ऊपर नीचे chlorine लगा दो अगर आप, sorry, into the इधर H2O लगा दो. सही है. इधर chlorine लगा दो.
नहीं. अगर ऊपर chlorine है तो नीचे H2O है. Like different compounds opposite to each other.
सही है. chlorine लगा दो. chlorine लगा दो. Then you have what?
Okay, according to one team, there's 2 compounds.
Huh.
isomers.
Two isomers.
So there's no cis trans here, or sorry, there's no optical here.
Yeah, optical. Yeah, normally octahedrals do form like optical isomers.
They
Tetrahedral में
do tend to do that.
tetrahedral
And
में तो बस cis trans ही होता है, but
octahedral may they form your cis trans, sorry, optical isomers when you have the chelates happening, right? When you have bidentate ligands.
true.
वो scene नहीं यहाँ पे.
So like what you're saying is, and that's probably likely. So like because we don't have any of the
So yeah, so
bidentate,
it's the green one and one of the red ones.
yeah.
So these are the two isomers.
So yeah, so
And
and you could call
wait,
I get
I don't think that's so right.
you could call this cis. You could call this trans. Ali किधर चला गया? Khair, I'm not too comfortable with this question, so like marking scheme से help ले लेते हैं. That's the beauty of Khair, क्या marking scheme क्या बताती है? Marking scheme is basically just okay. इधर तो तफरीह. Marking scheme is showing a cis trans basically. That's it. Yeah, marking scheme is showing a cis trans. So yeah, so that's more or less what we drew. हमने इस we just used H2O ऊपर नीचे. Whoops. So yeah, so can we move on to D?
You wanna like clean up?
Yeah, I don't know. मिट नहीं रहा सही से like. अच्छा, okay. Maybe if you have to be like very picky तो मिट जाएगा. Is Ali still there? Hello.
Hello,
Ali.
Khair. Ali is apparently not here for a few minutes.
Chalo, chillings. We can hopefully survive without him. We somehow managed to do the previous question, so we were good. Okay, so platinum 2 forms a 4-coordinate complex containing 2 ammonia molecules and 2 chloride ions. Write the formula of this complex, showing the overall charge if appropriate. And before we do that, generally the idea is that those transition metal ions that have D9, so like platinum, एक और भी था platinum, then there's platinum, I believe, or something, and there
Palladium.
yeah, sorry, my bad pronunciation. एक और
Palladium, platinum, nickel.
nickel. Is it nickel? We can check from the data book.
Yes.
Let's say.
It is.
So nickel.
I am looking at the data.
नहीं, but nickel का won't it go back into nickel is 3d8, so won't it form nickel 2 positive? Yeah, nickel तो मुश्किल है. Won't it be copper instead of nickel? Copper is 3d9 or 3d10 in fact.
Platinum is 3d8, by the way.
Sorry?
Platinum is 3d8, not 3d9.
Not 3d9. Platinum 2. Chalo, okay. So much for that jugaad. Sad life.
Anyway, 3d8 wale.
Are you sure about that? Platinum.
Yeah, it's beneath nickel. It's 2 beneath nickel.
Yeah, ये भी बात है. Platinum ion. Whoa, okay. 2 positive. Okay, so much for platinum. But yeah, so write the formula of this complex, showing the overall charge if appropriate. So you have platinum, you have 2 ammonia molecules, 2 and 2 chloride ions. This is 2, and the overall charge. If you look at this,
overall charge is 0 because 2 minus and 2 plus cancel
0
out.
and 1 chlorine minus 1, 2 chlorines minus 2, overall charge would be 0. This complex exists as two isomers. Okay, and again this is tetrahedral. So with tetrahedral कोई कहानी नहीं होती. It's
No, this
just
is
cis
not
trans.
tetrahedral.
This
Sorry,
is square planar
This is square
because
planar.
flat sum.
my bad, my bad. That's what I meant to say. Yeah. But
This
seriously,
is
हाँ. So tetrahedral में I believe दोनों हो सकते हैं, लेकिन square planar में like you just chilling होती है, like this cis trans. Draw the structure of these isomers. So you just show two into the plane, two out of the plane, and then you just flip that. You have platinum, you have A. So you can draw same groups one end पे.
That gives you cis.
Yep, this is cis, and then you just do the same thing. You just flip it for one. This is like the out of the plane wali cheese. NH3. So yeah, NH3. And if you remember AS, the idea is if different groups from
And yeah.
different areas. So yeah, that is trans.
And the two compounds are called cisplatin and transplatin because you have to name them as well.
Oh, and give their names. Sorry. So what
This
was it?
compound is called platin.
Platin. And how
Yeah,
do you know that name?
PLATIN. Because मैं सारे ने बताया था.
तो like अच्छा the popular complexes के names मतलब याद करने हैं. Like I don't think there's any other way to.
This is the only name we know. The rest of them,
Yeah,
you just
exactly.
know that.
That's what I was thinking. So okay, but let's just name one of them. Platin. Did I spell it correctly?
Yeah.
Okay. So one of the isomers in 2 is an important anti-cancer drug. State which isomer this is and explain why the isomer is so effective. Trans वाले है कौन
So
सा?
cisplatin is the anti-cancer drug.
Cisplatin. Okay.
This is effective because of the 3D structure of cancer, whereas the trans is not able to fit in with the thing. Basically, वो enzyme वाली चीज है.
locking की तरह ना.
Locking key की तरह है. So the cisplatin can fit in with the structure of the cancer and destroy it.
Okay.
I'd
Okay.
advise we look at how the marking scheme phrases it.
Yes.
Yeah. For theoretical questions like this, can react bond bind with
You don't
DNA.
need to know cisplatin. Just cis isomer.
Yeah. हाँ तो like name तो अलग है. Okay. So अच्छा नहीं so the key term is DNA. That's what I hate about chemistry. This like बेकार में like कुछ रटे वाली चीजें डाल देते हैं. Which prevents replication of the strand, prevents cell division. चलो, makes sense. So can bind or bond with DNA, and because of that,
Preventing replication.
yeah.
Yeah.
Okay, so transition metal ions often exist as hexa-aqua complexes in aqueous solution. The reactions which involve ligand exchange are reversible. Write an expression for the stability constant K stab for this equilibrium. Give its units. Okay.
So this is basically equation की constant की equation जैसे बनाते हैं normally, except you ignore the water.
And the reason for that is because aqueous होता है तो वैसे ही बहुत पानी होता है या क्या सीन होता है?
Exactly. Water is in excess anyway, so that just goes in to be the part of the constant.
Yeah.
Because its concentration doesn't change, so we call it a constant.
Okay. In this case, I can still give my two positive को अंदर रख सकता हूँ ना between the brackets
हाँ, two positive को अंदर रखना है.
because they mean concentration
And
here instead of the yeah.
Yeah, the
And-
brackets are for concentration.
And
Again, 3 to the power 4, and your other ion.
yeah, so H2O. Okay. होता है. And so units क्या है? This is concentration. So concentration is mole per dm cube, and if you take mole per dm cube and you divide it by would be mole power 4 dm minus 12
minus 12
in,
times mole per dm cube. With that, so one of them cuts out, and you get mole to the minus 4 dm to the 12.
yeah, slightly messy. Sorry. So what was the final answer coming?
Mole to the
Mole to
minus
the power
4
minus
dm. Well,
So mole to the minus 4
power 12.
dm power dm power
12.
12.
So yeah, basically just simplify the expression that we wrote above. That's the idea. So the numerical value for k stab in this for this equilibrium at 298 k is 1.2 into 10 to the power 13. Explain how this value relates to the relative stabilities of the two complexes. So it's like k stab hai, it's a concentration of the second complex over the basically the idea concentration of the first.
So the second complex is bigger, much bigger, which shows that it's more stable in the amine form, basically.
Okay,
Because the numerator is bigger, right? So the value is bigger.
so yeah, basically if it's just larger than 1 bhi to chalega na, like but you have your nh4 as well, nh3 as well, but either though it's a huge value indicating that your numerator is has a very large
Very,
value,
very big.
very very large value. So like so I don't want to write all of this again, but ये जो आपकी जो तफरी है, this boy, so it's much more stable than this guy. So do we have to explain this? We have to explain this. So as k stab
Is very large.
very large,
Yeah.
it should be good for 1 mark. And let's break it here, and we'll continue in the next video.
Sure.